Hello everyone and welcome back. Today I'm gonna talk about the nature of space and time. Can you taste space? Can you smell it? Do these questions make sense to you? Because when we think about space and time, generally, we mean abstract objects. Starting from our education, even in primary school, we are equipped with knowledge about Cartesian coordinates. And in it, we always identify space and time as these abstract and mysterious entities that run freely towards infinities. But is there more to the story? Well, if you ask to most scientists and physicists, the answer will be no. But as humans, we are more than just numbers. Because everyone knows that if you are having a good meal and with a good company, a long conversation can somehow shrink 10 kilometers of road into a 1 meter. Isn't this a length contraction? Or if you are having a good time in a lecture, that lecture can pass by in a second. Even if you are gonna, some people even say that if they are having such an adventurous life, their lives just pass by and now they are 80. There are lots of people like that. So the point is, as humans, we know that space and time and these objects are real entities. We can feel it. We can feel and live in it. Somehow these abstract entities are our homes. We live, we cry, we enjoy our lives in these abstract prisons that was made for us by a supernatural being, let's say. But is this the end of the story? Aren't we supposed to, as scientists, somehow explain these objects in a real way, in a physical way? Well, I think we can. And the story begins with Hendrik Lorentz. In the year about 1900, Lorentz, in a laboratory, observed something that has never been observed before. An object is so. An object with a length that was predetermined. Somehow, by moving in such a way that is so fast, that is close to even speed of light, let's say, he observed in a laboratory that the length of that object somehow shrunk. But how is this possible? Well, he postulated that because he was a classical physicist. And classical physicists, before those quantum and relativistic revolutions, tried to understand everything in terms of the language of classical mechanics, or let's say Newtonian mechanics. Of course, statistical mechanics probably is the only exception to that. That is outside of the classical mechanics at the time. But the point is, Lorentz, when he saw that phenomena in a laboratory, he tried to understand it in classical terms. And the most successful theory at the time in classical physics was classical electrodynamics, which is still such a scientific marvel. And learning it in an advanced stage today, even today, is in a graduate level. And it bears still some remarkable discoveries that is still needs to be made. So the point is, Lorentz tried to explain that length contraction in terms of the language of electrodynamics. And you will ask, why electrodynamics? Yes, at the time it was a very popular theory, but this wasn't the only reason that Lorentz did it. Because you see, all of the objects you see around you, they are held together. You and me and this iPad that is now taking this video are all held together with electromagnetic forces. And without these forces, these objects weren't supposed to be. That it is as simple as that. You will ask, why not other forces? Well, we have 3 other forces. Gravitation, which is very weak, and it doesn't help us to construct objects at a very small, by small of course, smallness is a very relative phenomena, because for example for a star we are something small, but for us, for example, an ant is small. So smallness, I mean an object that is, let's say, relative to ours. Well, in order to create an object at the size, you need electromagnetic forces, because gravitation is too weak for these forces, and weak and strong forces that are happening at around the scale of an atom don't help you to construct objects at these sizes. So electromagnetism should be, in a way, philosophically as well, be the reason that the object shrunk. That was Lorentz's point of view. So somehow the speed that the object is moving is affecting how those electromagnetic forces permeated around that object and shrunk it. This was the intuition behind Lorentz. So in a way, space and time, because what is length? Well, you will say, I will get a meters stick and I will measure its length. But isn't that a dimension, you will say? You are probably right. Probably that will be your answer. Well then, the length of that object has shrunk. This is what you observe. In a way, it isn't the length of the object that has shrunk. In a way, this can also be thought as your meter stick has shrunk. So your spatial dimension got somehow affected by electromagnetic forces, and maybe the interaction between those electromagnetic forces and the abstract object of space isn't something metaphysical. Maybe space and time and other dimensions, if they exist, all of them, even 11 dimensions in string theory, maybe all of them have an electromagnetic structure behind them that is still needs to be uncovered. But you will say, of course, Eren, if you were right, why didn't people develop these ideas after Lorentz? Well, the reason is Albert Einstein. Because Einstein, as you probably know, developed special theory of relativity, and in that theory, he was able to explain not just length contraction, but all the other puzzles at the time that was so at the center of physics, like ether problem, the non-existence of ether at the Michelson-Morley experiment. He was able to also somehow capture that aspect of the nature of space and time in his theory, and he did it with the help of his former professor Minkowski. He was able to come up with an abstract structure to capture the essence of space and time in what we now call as a metric. So in a way, space and time, in Einsteinian point of view, in classical general relativity, are abstract entities and are somehow only viewers from outside. They are not subjects in the dynamics. Of course, they are in a way interacting with the object, but their existence is assumed. That's why I am saying that their existence isn't, let's say they are just viewers. That's why I made that comment. Because in a way, of course, Einstein's theory of relativity was a step from Newtonian mechanics, as he was somehow able to explain the relationship between space and time and a physical object. But he couldn't explain the existence of the space and time and the nature and the constitution of space and time itself. And in this video, that's what we are trying to understand. But now I will go into a very controversial part. These are, starting from now, are my ideas. So there are analogies of creating a model of space and time from Einsteinian point of view, and you are able to capture these abstract entities of space and time and how they interact with each other in a refractive index profile. And the curvature of space and time in general theory of relativity are able to be replicated in a metamaterial, and that metamaterial is able to capture those abstract objects in its refractive profile. And refractive profile, if you study electromagnetism, is an element that is constructed by the electrical and magnetic permittivity of the substance, and in a way the coupling of those the coupling of electromagnetic entities replicates the curvature of space-time. So if you take these theories as literal, the space and time are just electromagnetic couplings, and this is actually the continuation of the point of view of Lorentz, as I just explained in the first part of the video. So in a way, what you are saying is that, similar to Lorentz, electromagnetic forces, in particular magnetic and electrical permittivities, are the ones who permeates around the object and make its length contract, not the abstract entities of space and time. Well, in a way, of course, the abstract entities of the space and time, but you know their physical constitution. They are electrical and magnetic permittivity. So time is a byproduct of those physical objects. But in order to extend these ideas of transformation optics to be literal, one needs to write Einstein's full dynamics in a refractive index profile. So unless someone does this completely and somehow capture the full theory with its full dynamisms in the refractive index profile, this philosophical argument cannot be even made. And in these days, physics is becoming very abstract. So with all the modern theories of quantum gravity and string theory, people are trying to explain very fundamental concepts in terms of abstract objects. So this kind of, let's say, alternative point of view can give a breathing space in physics. As in physics, as scientists, we need to explain what is physical in the end. So thank you for your time and stay with physics.